two OSGi tracks I have today. The first talk is going to be by Tim Ward. He's working for Arimus. He's also the co-chair of the IoT Expert Group. A lot of experience in OSGi. We're working with CPEC and we're working with the IoT Expert Group for a number of years. We're also the co-author of Enterprise OSGi in Action. So, welcome Tim for your talk. What's happening in the OSGi IoT Expert Group? Please do.
Right. Hello, everybody. So, as I've been ably introduced, I do a lot of things in OSGi and have done for quite a long time. I've had my fingers on a number of standards in the core platform and also in the Enterprise Expert Group. But I'm also really interested in asynchronous distributed systems, and it doesn't get more asynchronous and distributed than a big IoT system. So my IoT interests got me roped in to help launch the IoT Expert Group in OSGi. So the first thing I'm going to say is that we've got OSGi, and it is more than just a module framework. Because most people know OSGi and they think of, okay, OSGi, it's bundles and services, and that's what it is. And yes, it does do that. You are absolutely correct. But it is not everything that the Alliance does. The Alliance does a lot more than just standardize the OSGi framework. For example, there was a certification exam on Monday. I don't know if any of you here were there, but there was one. There are more coming up. There's one in Chicago in a couple of weeks. But there are also additional specifications, and these are things that aren't part of the core OSGi framework, but do offer features that people who write OSGi applications want to use. And there are actually 3 expert groups that gather the specific requirements that go into making these specifications. And that's how the specifications actually come about. So the IoT Expert Group is new. It is the newest. We were formed in July. And it's basically there to try and look at requirements that are specific to IoT applications. So it's a common ground, really, between the 2 other active expert groups that we have, being the enterprise and residential expert groups. So those are obviously ones that are working with enterprise software, so things that you'd find in big data centers, and residential things that you would find maybe in home gateways or kind of embedded software. The important thing is, we're not saying that IoT is a new thing that immediately needs hundreds of new specifications. We are going to be looking at how to reuse what we already have, because we thought long and hard about these things in previous years. And if we can reuse them, then that's obviously better than creating a whole parallel spur of IoT-specific stuff. But where we do have new requirements, we will extend the existing specifications, or we'll add new specifications as we see fit. That's what we're here to do. We're here to make OSGi better for IoT things. So, as I said, it's not a single standard. And we're actually coming up to the 10th version of OSGi, which is, so the one we're currently working on is called Release 7, and it is the 10th version. Make of that what you will. And actually each release version isn't a single standard, as I've said. You've got lots of things here. So we have these core, compendium, enterprise, and residential specification books that you see. And the core is actually the only one that is a single specification. It has quite a few chapters. It's reasonably thick, but it's the only one that's the single unit that you do everything in that book. And that's the thing that is the OSGi framework, which is why you have to do everything in the book. But the other specifications, so the ones that are the compendium, enterprise, and residential books, are actually split into chapters, and these chapters are independent from one another. If you're implementing, you implement one chapter and then you can stop. You don't have to do anything else. And this is actually quite similar to the way Java EE works. You know, people think it's odd that you've got this specification book and you focus on one chapter and that's it. But you look at Java EE and you have lots of slightly more intertwingle. You know, there's a lot more coupling between the things, but the servlet, implementing a servlet container doesn't require you to do everything that's in Java EE. And it's the same here. If you want to write declarative services, you absolutely don't also need to write a JDBC service. You just don't. And so this is all about modular standards. We do this on purpose because OSGi is a modular framework, so we should be able to choose the features we want and not pull in a whole load of other stuff that we don't. That's the whole point of having a modular framework. So, having said that everything's independent, there are definitely things that work well together and are intended to work together. We specify touch points between some of the specifications to say this is how these two things should interact. A really good example is if you want to put together a simple web app, then a combination of declarative services, config admin, and the HTTP whiteboard is a really good way of doing that. Using those three things together gives you something that's more than just the sum of the parts. And if you add a JDBC service to that, then suddenly you've got some kind of REST data access service. You know, so you put together the pieces that you need for what you're trying to build. And this is where, I don't know how many of you went to the en route tutorial, but this is where en route comes in. So you've got here a ready-built platform, which has a bunch of things that we think are a good idea to have for supporting your web applications, and to try and make that easy to use. Because we do understand you've got a book with maybe 50 chapters in it, and you don't want to have to read them all to know whether you care about them or not. And that's fine, and that's what en route is for. It's to give you the things that we think are useful for, in this case, writing web apps, and you can use the stuff, play around with it, and know that you're not having to dig through all of the chapters. It's also a really good example if you want to create your own platform. En route shows you how you can do that, how you can put together repositories of stuff, how you can make sure that you pull in the various bits that you want and only the bits that you want. So if you haven't looked at it, I do suggest that you take a look at enroute.osgi.org, because it's going to really help you to understand how the specifications fit together and how you can build a platform. So another really big benefit that we have, because all these chapters are independent, is that we can scope them by domain, and they can actually be applicable across multiple domains. So the JPA service is a good example of something that isn't really across multiple domains. It's pretty much the enterprise guys who care, and nobody else really tries to use it, because it just doesn't work well in, say, an embedded system. On the other hand, config admin, you want to use pretty much everywhere. I've yet to see an OSGi application that works well that doesn't use config admin. So we have these different specification books, but we have shared chapters between them. And the numbering's actually the same. So you can see that you had these two books, but you can read through and find the same chapter in both of them with the same number. So when you refer to it, when you're saying, I've got a problem, I don't really understand what's happening in this chapter, it doesn't matter if then someone picks up a different specification release. So you were looking at the enterprise one, someone else has a compendium in front of them. The references will still make sense. And there is quite a large amount of overlap. So for example, the compendium and the enterprise specs, I think there's about 20 common chapters. So there's quite a lot of overlap, and that's really good because it means that the OSGi specs, regardless of the domain that you're in, you've got quite a lot of common look and feel. You've got quite a lot of common understanding. If you know how to write a good, well-formed OSGi application, then you'll be most of the way to doing it on whatever platform, because these things are the same. So I've been here talking about the specifications. I do understand that I'm supposed to be here talking about what the IoT Expert Group is doing. So it's time probably for me to talk about what an expert group actually does. Because I've said there are all these expert groups and they make specifications, but that's pretty broad brush. You know, what are we actually doing? So the OSGi specification process, specifications exist because someone had an itch to scratch. That's why a specification gets started. And everything starts with a requirement. So this person has, this requirement, there's something that they need, and so they're going to come to us and we're going to say, actually, we should gather those related requirements and use them to write an RFP document. And the RFP, there's nothing about the implementation, there's nothing about how we solve the problem, but what it is it's a collection of related requirements that we think need a solution. And this is all published to GitHub, so it's publicly readable. And so you need to be a member if you want to actively update stuff. You can submit requirements as a non-member, but you can't actually go and start having write access to that repository. But you can read it, you can see all of the stuff that's going on. When it's ready, there's a vote. And an accepted RFP is one where we believe that the requirements have been gathered together, that the requirements all make sense, and that they are related, and that this is something that we should carry forward. Then at that point, the accepted RFPs are ready to be turned into RFC documents. And the RFC is where we actually start talking about the solution. So the RFP had no implementation detail, no how we solve it, just what the problem is. The RFC is different. The RFC is about how are we actually going to make something that works and is sensible. And they're discussed and debated, and it goes round quite a few times. And we do sometimes end up iterating over multiple solutions before we come across the one that is actually right, that really works. I've been on things that have not quite completely gone back to the drawing board, but have really substantially changed over the course of the RFC process. And that's important because it means that we get really good standards, because we've had a lot of eyes on them and we're prepared to really work on making them right, rather than just push out the first thing we think of. And then there's another vote. And that's basically to say everybody is happy with this, we think the RFC is done and it's ready to go and make a spec. And that's what the RFC feeds into. We use it to write a spec chapter. But that is not all we do, because we use the spec chapter to write both a reference implementation and the compliance test suite. And these are usually written by different people, and often people from different companies. And that's quite important. And the specification is only done once we have all three of these things. So we can't release a specification until we have a proof that it is working, because there's a reference implementation that passes all the tests. And then there's another vote, because we like voting. So once we've got a number of these chapters ready, then we create a release of the specifications. So this is where I was talking about the enterprise specs or the residential specs, and I'm saying we're on the 10th version of OSGi. So that thing is when we aggregate the new chapters that we've got into that book, and that's released. And this is happening probably every 18 to 24 months, on average, about that. There's no fixed cycle, although we try to make sure that it's not too long between releases, because obviously the longer we have between releases, the longer people have to wait to actually get a successful implementation going. And all of this may seem complicated. I'm aware that it's been a few slides, but the really important thing is that it makes the specifications really high quality. We have this thing that we call the three-legged stool. You've got the RI and the CT and the specification document. And it's really important because each of these is testing and proving that the other things have been done right. because you can't write a reference implementation from a spec that doesn't make sense. You know, if the spec is vague, if the spec says that you do two contradictory things, then you're going to find that out by having someone write a reference implementation. And it's why it's actually really important to say, have a different person write the reference implementation from the person who wrote the spec chapter. Because if you wrote the spec chapter, you're going to write the implementation because you think you know what it's supposed to do. But actually reading it as a separate person and trying to do it is proof that the specification is written well enough that lots of people are going to be able to do this. Similarly, the person writing the compliance tests is again going to have to read that specification document. And they're going to look at the wording and they're going to say, okay, I can write a test for this because it says that it's got to do this. But in this one, you've said, you know, you can do this. What does that mean? Does that mean that I can write a test that says, yeah, you did it? Or can I not? Because you've got the option to not do it. And those things really help to tighten up the spec document. Obviously, the tests make sure that the RI is actually doing the right thing. And the RI also tests that the tests are doing the right thing. Because you can get some quite interesting arguments between people as to whether it's the reference implementation or the tests that are wrong. But I digress. And the thing that I was saying is it's really important that at every stage there's iterative improvement. So we start with something which is, you know, a big block of requirement stone, and we chip away at it and we chip away at it until we've made it as simple as possible, but no simpler. And we may sometimes start, you know, massive block of stone and we end up with just a tiny pebble. But the fact that we get a really tiny, perfect pebble is much better for users of the specifications than if we have a much bigger rock that maybe does more stuff but has sharp edges that you cut yourself on every time you try and use it. So that's what an expert group does. An expert group goes through that cycle to produce specs. So OSGi and IoT. Well, I'm here talking about IoT. We should probably define what IoT is. And this is the only thing that I can say with absolute certainty. IoT is an industry buzzword, because nobody else really agrees about what it is. There are common themes, but lots of people talk about IoT and they say they've got an IoT strategy, but you look at it and it's not really complete. There are holes. But there are common themes, and there are two of them. One of them is internet, which is good because it's in the name. But devices are connected, and they're connected at both a local and a global level. What I mean to say is, it's not enough to say, my smartwatch is talking over Bluetooth to my phone, unless it's also then doing something through the phone that's going out to something else. Because a local network isn't really Internet of Things. We're talking about something that's broader than that. Similarly, there are things, which again is in the name, so that's good. But it's important to realize that the Internet of Things does involve real objects. There are things actually interacting with the world, measuring the world. And if we forget that, then we end up with all these kind of virtual Internet of Things type stuff, but it's not really an IoT application. You've got the OSGi IoT demo upstairs, where we've got a Lego train running around. It wouldn't be an IoT demo if we weren't actually having motors in the train and on the switches that were physically changing. It would just be some kind of virtual software emulation thing, which is basically just a computer game at that point. Now, this one is one that is slightly contentious, but is also fairly commonly accepted, which is that the things in the Internet of Things are relatively cheap, low-power devices, and they're pretty dumb. You're not talking about something that's got an Intel i5 or i7 processor. We're talking about something that doesn't have much compute resource. And there are also typically quite a lot of them, because if there weren't, then life would be a lot easier. So the thing that we find is that these low-power things can't normally use TCP/IP, which makes it pretty hard to use the internet. And this is why you've almost always got some kind of gateway that's IP-enabled. So I said about you've got your smartwatch, so Fitbit or an Apple Watch uses Bluetooth Low Energy to communicate with your phone. You've got industrial sensors that are using, that's the IEEE standard that leads to things like Zigbee, and they talk to an Ethernet bridge using that. The gateway is then actually responsible for doing some stuff. So it will filter and aggregate the data and then forward stuff if necessary. But it's really important to remember that the gateway isn't just some dumb access point. It's actually doing some work. It's more like a biological system. If someone takes a hammer and hits you there, you kick. And that signal never makes it to your brain. It's handled by your spinal cord about here. And that's exactly what the gateway is doing. The gateway is taking some kind of sensor stimulus and then doing something and making a decision, which in this case is locally, I'm going to react, but I don't need to tell the brain about it because it's not important. It's important I react fast now. So for example, your gateway may immediately send something to your fire alarm to say, fire alarm, go off now because there's a smoke detector over there that's saying there's smoke. And you don't want to have to wait to call the cloud to tell you, oh yeah, you should probably set the fire alarm. So another good example here, we've got things where you can alert based on a sensor reporting overheating in your industrial platform, or your mobile phone just occasionally uploading statistics to the cloud about what activity you've done today. But it's important to know that the gateway was the one that made the decision to do that. And this comes into why OSGi is actually good at this. Because whilst the things are pretty constrained, you probably aren't running Java, the gateway probably is. Most gateways do. And OSGi was actually originally designed to do exactly this. It was a residential gateway platform. It has also proven to be really good at running on the server. And that means you've got this ability to have the same platform in your cloud and on the edge. And that's a really good thing because it means that there's no impedance mismatch between what you're doing at one level and what you're doing at the next. People have some kind of logical ability to work through and understand what's going on. It's also important that OSGi is both dynamic and remotely manageable because edge servers, you've got to be able to update them and you've got to be able to do it easily. And things, dynamism is important because things come and go or break, and that happens a lot because there are lots of them. And just to emphasize how important this is, if you've got a dynamic system, it will self-heal because it'll rewire itself once the state changes. It'll correct itself to reflect reality rather than the XML document someone wrote that says, this is how my IoT system should look. And this is a really good model for OSGi services because these things come and go as well. So think of losing a server in a server room. It's kind of bad. If you lose a whole rack, then that's when a lot of phone calls start happening because suddenly you've lost a lot of compute resource and probably a lot of application hosting at the same time. If you didn't really think things through and a lot of servers were on that rack running the same application, you may actually have lost enough of them that the whole application goes down. But in IoT, this is kind of normal. Losing a whole rack of stuff is just, it happens all the time. I took off my watch and I went out of the house. Oh no, I've just lost the whole of that piece. I rebooted my home router. Oh God, everything in my house is disconnected. That must mean my house is blown up. In IoT, there is a continuous state of catastrophic failure because somewhere, something is going to be off or not working. And OSGi is designed to cope with this. OSGi is a system that can cope with regular and sustained catastrophic failure and then keep working afterwards. It takes a licking and keeps on ticking. So that's why OSGi is doing this work with IoT. The IoT Expert Group, therefore, as I said, created in July, and there are lots of OSGi member companies that are already participating. We're having regular calls, so this is where we discuss. At the moment, we've only got RFPs because we're kind of too new to have any that we've successfully voted through yet. But we've got calls where we're talking about requirements and gathering them together. We've got a face-to-face meeting in January, and so prior to this, there were a number of IoT workshops, and these were open to the public, and we used them to gather people's IoT requirements, and they're helping to feed the first set of RFPs that we're creating. So we actually talked to real people, and that's how we got our initial requirements in. And we actually have several active RFPs already as a result of this. One of them is about malicious bundles and security. So obviously security is important in IoT because you're handling relatively sensitive data. How do I know that this bundle I'm installing is safe? I'm going to be pushing it out to maybe hundreds of thousands of end users. I should probably know that it's not going to do anything bad. We've got permissions and code signing already in OSGi, but that doesn't stop you from making a mistake, from doing something silly that opens up a big security hole. So what we've got here, we're looking at code quality and safety in the application. We're going to be creating probably a set of security guidelines. The reason I say probably is this is still an RFP. We're not necessarily done yet with working out what it's going to be. We're certainly planning to do something about reporting known vulnerabilities to people, so you can go and look and find out what maybe you should be avoiding or what you should be doing to try and fix certain problems. And potentially there are going to be some independent test suites for the framework. So RFP 177, sorry, I should have pointed out, the ones here that have RFP numbers, those are ones that you can find publicly on GitHub. They're live now. You could look at them right now, assuming the Wi-Fi is still up. So RFP 177, this is IoT protocols. And this is because I said earlier, you're not just typically using IP for talking to IoT devices, the actual sensors and actuators, because they need something simpler or different, because just IP isn't the right thing to use. And this RFP is basically collecting requirements for how we should be doing that conversation. Now, there are already things from the residential expert group about using things like ZigBee, using things like USB to talk to things, but we've got things like MQTT and COAP, and these are things that we're really looking to try and integrate better. And we want them to work well as OSGi primitives. We want people to be using this stuff and not say, oh, well, I'm having to do something weird because it's MQTT. We want them to just say, okay, I'm using it like I would any other kind of OSGi bundle. So this will let you decouple the protocol, the transport, and the processing logic from one another. You will be able to reuse the same bundle to do things like maybe temperature management in your house, regardless of whether the thing is connected over an I2C bus or whether it's talking over ZigBee or Z-Wave or whatever. It won't matter. You've still got the same business logic, and all you're changing is one of the bundles that says, okay, how do I actually physically talk to this thing on the wire? And the rest of it doesn't need to change. And that's why modularity is good. We're now on to some of the RFPs that don't have numbers, and that's because these things we've been talking about, but nobody's actually put fingers to keyboard and written this stuff yet. But remote device templates. So these are, we've got IoT devices, and I've said there are lots of them. I've been purposefully non-specific about what they are, because there are huge numbers of things that you could consider an IoT device, and they've all got different interfaces. And having a different access layer for talking to each of these is totally impractical. You don't want to have different adapters for every single kind of light switch, and then every single kind of door locking mechanism. It would just become ridiculous. So, and you also don't want to have to update your software every time you buy a new light switch that happens to be slightly different from the previous one. So what we're doing here is collecting requirements for device profiles that are trying to make these things self-describing so that we can do things like write a descriptor that's going to publish information about what this thing is and how you interact with it, so that you don't need to go through and have a different adapter for every single kind of thing. you can put it all into a common format. So, getting involved. How do you actually get involved with the IoT Expert Group, or maybe one of the other expert groups in OSGi? Well, anyone can submit requirements, and you do that using the public Bugzilla. And I mean anyone can do that. That's absolutely fine, and we would encourage you to, because it's good to know what people actually want. You can also follow the expert group's work on GitHub. As I said, you've got every single RFP and RFC that's being worked on is visible in that GitHub repository. It's an open process, they're open standards, you can see how they're progressing. If you want to actively participate in the expert group, then that does require that you join. You need to be a member to join the calls and discuss things like how we're going to solve particular problems. One of the main reasons for that is actually just intellectual property law. It's very difficult if you've got people joining the call, you don't know where they're from, you don't know the provenance of the IP, and things get very sticky. So it's important to be a member so that all of the rules around IP within the Alliance are able to be followed. But the lowest level of membership is enough. You don't need to come in and pay huge sums of money and be on the board in order to do this. If you just come in at the contributing associate level, you're allowed to contribute. It's why that level exists. And if you participate in one expert group, that doesn't mean you're excluded from the others. I told you I've written specifications across several of the different expert groups, and one person can be in several. That's absolutely fine. So that's kind of what we're doing. I've talked you through the RFPs that we're currently talking about the process and how we're going through with it, and how you can get involved. So just, if you've got questions, please ask them. Yeah?
How much members are just part of the IoT Expert Group, which members?
So just part of that and not part of any other group? Or?
Just about how join calls and meetings on a regular basis.
So we're well into double digits now. So I'm responsible for putting the statements of work in. You need a signed statement of work to say you're actively participating in the expert group, and we're definitely into double digits. I think we're 12 or so, but we've got more people who are in the process of signing it. So I don't know what the number is right now, because I've not been checking that particular email inbox while I've been here.
Just more to add to it. Recently, there has been an announcement yesterday that 3 new members have joined the OSGi Alliance, Eurotech, Huawei, and Bitreactive. I know that at least 3 other members will also join just because of the IoT Expert Group.
So,
and in addition, sorry.
So that would take us up to like 20 or so by probably the end of the year.
Important to know is that we are also reaching out to other standardization organizations. All the other organizations are reaching out to us. So we've started a partnership with ISC, and I currently work on a partnership with one of the others.
Okay, thanks.
Question from the back. David.
Yeah, it's not really a question, but something I kind of wanted to add to what you were saying, which I think sets OSGi expert groups apart from other organizations, and that is that it's really democratic. It's, I mean, in other expert groups, you have the spec lead, and he takes advice from everybody else, and they can still do everything his own way. In OSGi, that doesn't happen. In OSGi, it's very democratic. Everybody has the same power, the same vote. Every company has one vote, so it's really, it's not kind of ruled by one entity. It's really kind of about getting consensus and just keeping going until that consensus is there, and I think much more than in other organizations. So that's, I hope you don't mind me adding that to your...
No, I think I mentioned that we vote a lot. Yeah?
What are the acceptance criteria to participate and get involved in an expert group like the IoT one?
So if you want to be involved in the IoT expert group, you need to be part of a member company or an invited researcher, and you need to sign a statement of work that basically just says you're going to be participating and you agree that the discussions you have may end up in a specification, and you can't then say, no, you can't have that IP. That's basically it. It's sign a couple of forms and be a member.
But other than that, there's no other requirements. Feel free to join.
Yeah.
You don't have to do the OSGi exam or anything for you to participate. Sure. What do you think?
And what about small companies? So, sorry, two questions in one. What about small companies? What is the barrier for small companies to join?
None. But you have to pay. But there are different fees depending on the size of the company.
Okay.
So the lowest level that we have is the CA, contributor associate level, which is $5,000 US per year.
But it's less if you're a small company, isn't it?
That's the next level. That's principal is.
Principal. It's
Well,
5,000.
But if you pay and get a vote, a small company vote is equivalent to an IBM vote,
Exactly.
or is equivalent to a
Oracle or
SAP vote or an Oracle vote. You get exactly the same voting rights as a large company.
Which might be known by heart.
BitReactive has only 8 employees, and they just joined.
Makewave, you're 7.
MakeWave has 7 employees and has been a member for 15 years.
Right, I'm conscious of the fact that I'm probably now very slightly over, but please do evaluate the session, because I'll get told off if I don't say I put this slide up.